It's been a dream of mine since I was 13 to make an audio plugin, so I'm incredibly excited to share our first plugin with y'all, Sage Velvet, which will release on December 8th. Now in this video, I really want to avoid the traditional marketing hype type stuff and show you what the plugin does, how it works, why I made it, what's going on behind the scenes, explain one negative thing about the plugin, which is its high CPU since it's using some advanced processing, and of course, listen to some demos. Now, by the end of the video, you can make an informed decision on whether it'll be beneficial for your projects, and then when it's released, there's a 14-day trial, which I encourage people to try before making a final decision. Now, I really love how it sounds, but I'm sure I'm biased, so I want to get as many people's thoughts on this as possible so we can make better and better plugins with each release in the future. So the plugin is an emulation of a popular hardware unit, primarily the transformer saturation circuit of this unit. Now, I have and use one of these units on just about every recording that I do, whether it's for myself or for other artists. I genuinely enjoy its sound that much. Now the problem is that the unit, for most, myself included, is prohibitively expensive and it's mono. So retracking or mixing with it really isn't an option since you'd need a lot of units to do that. The second problem is that traditional digital processing can get kind of close to mimicking its sound, but it falls short if I'm being honest. Now as many of you know, digital is fantastic, but whereas a plugin can typically handle a couple of hundred variables, analog hardware can have thousands, tens of thousands of variables and nuances that would take a plugin developer an absurd amount of time to try to code. Now with that in mind, I created an incredibly accurate recreation that I could use on my mix bus, my instrument buses, or during a mastering session. So what I've done to do this is take a newer technology, neural amp modeling, and I captured an incredibly faithful recreation of the unit. By running intentionally designed signals through the unit and having machine learning interpret the output 1,000 or so times, I now have a model that recreates as many of these variables as currently possible. Now, in case I've bored you already, let's take a listen to the original unit saturation circuit and compare it with Sage Velvet. First, we'll listen to the red circuit at max settings, and then we'll listen to the blue circuit at max settings. Let me know if you notice a difference between the original unit and Sage Velvet. Now to my ear, the unit's red circuit does sound just a tiny bit smoother in the highs, but I really have to focus to hear that much of a difference, and even then it's not significant. I may release a free update for the plugin in the future if I'm able to create a better model for the red circuit, but for now, I'm really happy with the results. Now Sage Velvet can actually do more than the original hardware unit. I wanted to introduce some features that in an ideal world would be part of the hardware. So let's take a look at these additional features. First, we have the main saturation unit, which could be introduced subtly, moderately, or more aggressively, and vary between red and blue. But you might have noticed from the demo that the hardware is pretty subtle, even at its max settings. So I added this gain compensated drive dial. With it, you can increase the input into the circuit by up to 8 dB. The boost is automatically compensated for after the circuit, so you only hear the additional saturation, not the amplitude difference. Following this idea, I added the emphasis de-emphasis filter. If you emphasize a frequency range with an EQ before a saturator, that boosted range triggers the saturation more often than other ranges. This causes harmonics to form from that boosted range. By varying the center frequency of the boosted range, you vary the harmonic formation. To do this, you typically need an EQ before and after the saturator, the first to boost and the second to attenuate what you boosted so that the response stays balanced. But I've built this into Sage Velvet. You can boost a range into the saturation circuit. Meanwhile, a de-emphasis band is instantly created after the saturator to balance the frequency response. So it's a very quick way to achieve the technique without the need for additional equalizers. Lastly, we have a stereo width function that amplifies the mid or side channel, again, with automatic gain compensation. 50 is the original width, moving toward 100 increases the width, while rotating towards 0 decreases the width. The peak value stays about the same within about a dB, so you can make width changes without the loudness affecting your decision. Now, if you want to increase the width, but keep the low centered, there's an internal high-pass filter that excludes frequencies below the listed value from being processed by the stereo imager. So on top of the highly accurate saturation model, we have some additional digital filtering to add some versatility. So let's take a listen to these additional filters to get a better idea of what they do. Next up, let's take a look behind the scenes. So Sage Velvet doesn't behave like traditional plugins. This isn't to say that the plugins we've been using for the past 20 or so years are bad, just that they have fewer nonlinearities. For example, a hardware unit may respond differently to 200 Hz than 300 Hz, or even 200 Hz at -20 dB compared to 200 Hz at -19 dB. However, since every nonlinearity would need to be coded, most plugin emulations are simpler due to the sheer amount of time it would take to accomplish this. Sage Velvet, on the other hand, uses neural amp modeling and has recreated an astounding number of these nonlinearities, resulting in an extremely faithful recreation of the original unit. To measure the nonlinearities, let's do something called a Hammerstein test. If I use a plugin designed to be clean and avoid nonlinearities like this Pro Q3 EQ, the changes will look exactly like the filters we create. If I dip 500 Hz by 30 dB, the test will show the same thing. The sine sweep was 0 dB for all frequencies from 20 to 20 kHz, so introducing this filter is represented as the same dip. But saturation is more complex. If we use this Kramer tape plugin as an example of traditional digital processing, not as a direct comparison to the processor we're emulating, but as a good baseline, so to speak, we'll notice more variation. But let's compare that to the hardware unit we've recreated with Sage Velvet. The nonlinearities are present throughout the entire spectrum, and in a significant way. Put side by side with Sage Velvet's test, we'll notice they both share this immense complexity. In both, the amplitude of the signal and the frequency matters significantly. It may not be the exact same as the hardware, and in all honesty, I had a little trouble ensuring I got as accurate of a reading as possible from the hardware due to the routing, the cables used, and the levels of the signal fed into the hardware, but the complexity is present in both. Again, compared to traditional plugins, the difference is night and day. Last up, let's cover some important notes. Now, although Sage Velvet is significantly more complex than most plugins, that does come at a cost. That being, this plugin is CPU heavy. Unfortunately, using a stereo neural modeling setup is, by its very nature, a lot of work for a computer, and there's no way to circumvent that, at least for the time being. Now, that's why I want to urge everyone to try the 14-day trial before deciding on purchasing the plugin. I don't want you to purchase it and then have your session slow down due to hardware limitations. That said, this plugin is meant to be used sparingly in a session, mainly for instrument and mix buses or during mastering. And as computers improve, Sage Velvet could be used more during a session, but for the time being, it's a highly accurate and complex processor, but one that requires a lot from your computer. Lastly, the neural amp model used in the plugin was captured at a 48 kHz sampling rate. For the best results, use Sage Velvet in a 48 kHz session. So I hope this video has been helpful, and I'm incredibly excited to share this plugin with you all. I'd love any feedback that you'd be willing to provide, since that helps me know how I could improve plugins in the future. Sage Velvet will be released on December 8th. There's a 2-week free trial, which I encourage you to try first, and if you choose to purchase it, the cost is $19. Thank you for watching, and I'll see you in the next video.